In complex analysis, we have the fundamental operations of complex numbers. So number one, we have addition, and then we have subtraction, we have multiplication is number three, multiplication is multiplication, and then you have the division. So it is the basic arithmetic operations that we usually deal with in mathematics. Only it will involve something we call complex numbers, something with I. So that is the only difference. So for example, let's start with our buddy here, our friend called addition. So say you're asked to add the number z1 is equals to a plus ib, and z2 is equals to c plus this. And then maybe even then you're told to find the arithmetic of z1 plus z2. So you're going to just add this as you would add 5 plus 3. If you add 5 plus 3, you just add them together, right? So in this case, you're going to say a plus ib plus c plus di. Then you group the like terms together in such a way that you're going to have a plus c plus I b plus d. You open the brackets. So now that is the basic mode of operation. So now let's now have a tangible example. So for example, let me just write this because so let's have this as a constant. We say z1 is equals to a plus ib, comma z2 is equals to c plus di. So in the case of addition, we say z1 is equals to 3 plus 4i, and z2 be equals to 5 plus 7i. In terms of addition, we're going to have z3 is equals to z1 plus z2. We are going to deal with this. So what you're going to do, you're going to say 3 plus 4i plus 5 plus 7i. I said you group the like terms together, so this will be 8 plus 11i, and that will be the answer. In terms of subtraction, you will have the same z1 as this and z2 as this. Then z3 will be given as z1 minus z2. Like as you can see, it is the basic addition and subtraction. The only difference is this I. So if you are told to subtract this, it's going to be like this. Again, you group the like terms together. So 3 minus 5 will give you negative 2. 4 minus 7i is going to give you negative 3i. And that will be your answer. So sorry for the silence. I do not want even to over edit my videos in any sort of way. It's just that because I'm explaining to myself and I should be comfortable, I'm seeing this place where I wrote that R is equals to Z3 is equals to 8. So for Z3 equals 11. That's what I'm trying to understand. So Z4 is equals to Z1 plus 272. So 2Z, is it 27 or 2Z2? 2Z2. So that it can be 2 multiplied by Z2, 5 plus 7I, and Z1 is that, and then Z5 is equals to Z1 plus Z2, which is the same as taking Z1 minus plus Z2. Where is Z2? Yeah, it's basically the same. Hence, the real part is equals to Z3, and Z3 is equals to 11. Let's continue with the explanations. So the next complex analysis is the next fundamental operation is multiplication, where Z1 is equals to AI plus B, Z2 is equals to C plus DI, and you're told to find Z3. I'm a bit confused, I'm repeating the same things, sorry for that. So when you fall to find Z3, it is going to be equals to A plus BI plus C plus DI. Then Z3 is equals to 3 plus 4I multiplied by 5 plus Z1. Because, there's my head here. Because the question says Z1, Z2. So when you want to multiply this, it is going to be 3 open brackets 5 7I plus 4I 5 plus 7I. So you're going to have 15 plus 21I plus 20I plus 28I squared. Let me see. This is 15, this is 21, this is 20I, this is 28I squared. And I squared is equals to -1. Let me see. A squared is equals to -1. So our final, what's this? 21I. So this will be 41I plus 15 plus 28I squared. And where we have where we have 38I squared, we say I squared is equals to -1. So -1 multiplied by 28 is -28. Negative times positive is equals to negative. So you replace that and say that is -28, -28. Let me rewrite this at the top. Our answer was 15 plus 41i minus 28, because I said I squared is equals to negative 1. Hence, this will be negative 28. Then that 15 minus negative 28 will give us negative 13. So our answer will be Z3 is equals to negative 13 plus 41 I. So that is the answer. And then finally we have division of complex numbers. So whatever will happen here is basically you're going to multiply it with the conjugate. And what I mean is we are going to have Z3 in this case is equals to Z1 over Z2. So this is A plus IB over C plus DI is equals to 3 plus 4i over 5 plus 7i. So you're going to multiply the entire thing with the conjugate of this. So we are saying we're going to multiply the C minus DI. So in this case we're going to multiply the numerator and the denominator with 5 minus 7i, and then you're going to open your brackets. So our answer will going to be 3 5 minus 7i plus 4i 5 minus 7i over 5 minus 7i plus 7i 5 minus 7i. Our final answer is going to be, tell me whether you're going to get the same thing, or maybe I should just calculate it. Where are we rushing to? So when you open the brackets, you're going to have 15 minus 21i plus 20i minus 28i squared, but 28i squared is equals to negative 1. So let us just write it first like that. Then you're going to have 25 minus 35i plus 35i minus 49i squared. I'm going to go slowly because I love slow things. So confirming 15 minus 21i plus 20i. This looks weird. 21i. So 15 minus 21i plus 20i minus 21i squared. Then 25 minus 35i plus 35i minus 49i squared. So when you change this is negative, then negative times positive. Let me show you times again. This will become negative 1, and this is also negative 1. I squared is equals to negative 1. So our equation is going to be 2015 minus 41i plus 28. Finally, we are going to have 25. This will cancel out, minus, no, positive, negative, negative, positive, plus 49. So you're going to add them. So this will give you 28 plus 15 will give you, is it 43? So 28 plus 15 will give you 40. Need to confirm. Yeah, this is 43 minus 41i over 25 plus 49, because 74. And that should be your answer. Yeah, so that is the entire concept of division. So you're going to multiply. So what you're supposed to note with division is you're going to multiply. So division is you multiply with the complex conjugate. You multiply with the complex conjugate. So what you mean by the complex conjugate is the denominator, then you add a negative. So you have the denominator, then you put negative. I hope you get me. Yeah, and that brings this video to an end. Then next time I'm going to revise on absolute values and some practical applications of complex analysis, like current and voltage and computing I squared.